Hi guys. So today I will demonstrate the demo of Proxy and NAT and the file transferring from HuggingFace to enclave and from enclave to S3 bucket. So as you can see, the enclave itself is already running. So here's the starting command and memory started, the allocation of memory started, and here's the output of the kernel log. So this, the third window in the GNOME console, is the this is the enclave console. This is the local server console in unprivileged mode. This is the root privileged console. So, and this is the monitoring panel with the htop utility. So as we can see, we utilizing 820 gigs of RAM for enclave and some remaining part for the system. So let's start. Maybe better to somehow separate the consoles, but yeah, that would be fine. So here's the special command. So let's start. So make, this is the installer. It gives us the prompt deploy networking components, and I say yes, and here's the networking components have been deployed into the enclave. Run networking components. So yes, and here we also see that the configuration have been applied. First of all, we see the networking interfaces. Here's the local loopback. So here we started the socket server for DNS. Enable the rules. This is the destination port aggregation. So this is the dump of the rules. So we've got the so we have the instances already running of the proxy, and DNS is also running. Cool. So the next part, installing the essential RPM package. This is basically the Python package index. Yes. Yeah. So okay, the Python PIP started. and completed. So as you can see, we started to install the Python package index, so pip tool. So it is installed completely. Good. Now we installing the HuggingFace CLI toolkit. Install, yes. Okay. So all components, including HF transfer, have been installed inside enclave. And this gives us basically all this actions gives us information that networking inside enclave working fine. Download models using HuggingFace CLI toolkit. So it's basically we'll download the Mistral 7B and Llama 3.1 8B. Two models. Let's see. Using the HuggingFace CLI toolkit. Okay, it is running. So we are filtering out the output of the proxies itself to files rather than to the enclave console, because just to clean it up, clean it out the output. Okay, looks like it is running, but I want to make sure that the proxy is working and working properly. So I will go to the pf build. pf build directory, to the logs, dot logs. Okay. Good. What we have right now here is that so basically we're downloading the model files. It just consumes a bit of a time because although we installed the HF transfer module, but we are not enabling it because this module is pretty simple. It's a brute force then loading module written in Rust and integrated through PyO3 to the main HuggingFace toolkit. So right now we're using the main Python-based HuggingFace toolkit because the module HF transfer has the better handling, and it cannot work properly after behind the NAT proxy and handle the errors, networking latency errors, basically, because we have only one instance of the proxy, and proxy just cannot handle all that kind of multi-threaded requests from by this tool, because this tool just utilizes the full bandwidth and multi-threading mode way beyond its strengths. So let's see what's happening in the logs actually. I want to look at the okay, that's good. That's actually good. Okay. So the traffic is going back and forth. That's great. In Socket we also has the logs. And there's one log that I want to look at. Okay. Yeah, looks like the socket just works properly. It resolved the names. Basically it's a UDP proxy which transfers the DNS requests to host local DNS server. So maybe not so super interactive when we filter out the logs of the proxy to the console, from console to the files. So what we have here, Let's see if we have some activity, because yeah, we've got some activity, but the performance isn't so great. So that's why it's better to download the clean models, not to the enclave, but on the host system, and then transfer the model into S3 bucket for clean models for the cache, and to the enclave using the local pipeline, secure local channel. So here the installer just waiting the prompt for transferring the model to S3 bucket, but first of all we need to download it. Okay, it was downloaded actually, so we are fetching the 15 files successfully, and this is the Mistral 7B. Okay, and Llama was also downloaded, so fairly fast. Can be faster anyways with the HF transfer module, but yeah, on a host system, not behind the NAT proxy. The guys should perform more work on the HF transfer error handling to support the proxy properly, and working behind NAT. So not every application, unfortunately, has the good support of the enclaves. I mean the proxies and NAT, and work behind the proxy and NAT. Okay, let's see if we have these files in the modules. Okay, we can make this like that. Recursive models. So okay, this is the Mistral 7B. We've got safe tensors. Here's the huge safe tensor files, like 15 gigabytes, and in consolidated safe tensors, which is the 14 gigabytes. So that's for the Mistral. What about Llama? With Llama we also have that consolidated 15 gigabytes files. And yes, we've got all of the 4 segments of the safe tensor files. So it was downloaded successfully. Let's see how it will be uploaded to the S3 buckets. Again, this is the enclave console, this is the installer. I say yes, so we are transferring this to using the S5 CMD tool to our S3 bucket. Here it is. We are transferring. Yeah, the S5 CMD has the good support of the proxies, so that's why it's tremendously fast. We are utilizing something like let me check. Huge. Something like, so basically more than almost 900 megabytes per second. Is the outgoing traffic. And 900 is the actually is like okay, looks like we are finished our transferring. Pi 8 and divide by megabits. So this is the megabits. So we've been utilizing the 7.5 gigabits using the S5 CMD. Yeah, really good. So the transferring is done. Let's actually see if it was transferred. For that, we will use the command. So basically, we can use the, for example, rclone. Like yeah, probably the LSD. Yeah, here it is. So we've got both of them here, and list the files. Here they are. Yeah. So all model files are transferred. This is the 4 safe tensor layers from files, the segments, the parts of the safe tensor layers from Llama, and 3 of them from Mistral. Consolidated also here, and yeah, here. So looks good. Let's transfer using the AWS CLI. Okay, it started to work. Yeah, AWS CLI is not so much performant, but it can utilize up to 150 megabytes per second, maybe more. Let's see. So we're transferring the Llama first. And Mistral as well. So it looks like the both models are transferred in parallel inside the enclave. And the HuggingFace was also working. The HuggingFace toolkit was working in parallel inside the enclave. Yeah, well, we are utilizing, this data is not so much the same as this one. So it looks like we have a double speed utilizing, like 300 megabytes rather than 150. Here's the number of the transmitting. Receiving number and transmitting number of megabytes per second. As you can see, it's also utilizing the multi-threaded mode, but yeah, all applications works differently in downloading and uploading. So even AWS CLI has the just parallel to everything. So we see how the transparent proxy works here in Tokyo runtime. So almost done for the Llama and for Mistral. So this is like 300 megabytes per second, and this is the 27 to 30 gigabytes modules. Llama obviously has the weight of 38 gigabytes. Do we actually have So yeah, looks like the transferring have been done. Okay, yeah, it's done. Let's try out the air clone tool. So here's the air clone working. Okay, again, it is reported about the. It will also utilize something like 150 or 300 megabytes per second, but it is reported like wow, like S5 CMD as well, so around 800 900, so something like 7 gigabits per second, 7 to 7.5 gigabits per second, and from 800 to 900 megabytes per second. Fairly good performance. This is the, by the way, everything on the host system. So right now it is transferring the consolidated safe tensors from Llama and from Mistral in parallel mode. So fairly good performance from my point of view. Yeah, our clone is almost like S5 CMD. Only HuggingFace has the problems with the multi-threaded mode inside enclave and with the error handling due to the latencies. Good stuff. Yeah. Okay, it's 100% done. All good. So our installer was done. So we just passing through the all steps. Let's check out again if everything just fine. Yeah, there's a bit latency here. It's inevitable when we use the Proxy NAT because it should open the connections first and then we will utilize that connections. At some point, yeah, in the future we will figure out how to improve that. I mean the Proxy NAT runtime to improve the decrease the latencies. So this way we will decrease the waiting errors because everything here is relying on timers, waitings, and tolerance to that networking latencies. So if we can decrease that, and made the proxy runtime more responsible, more flexible, more scalable. So we can reach even greater performance and network utilization. But even now it works on a really great level. So 7.5 gigabits inside the enclave, 13 gigabits or almost 15 gigabits sometimes on the host system. So HuggingFace, I mean, if we need to transfer such kind of modules like Llama 70B, so we can run this on a host system and transfer from the host system to S3 bucket for clean models and right inside an enclave using the pipeline secure local channel. So everything works fine. So we can just exit from here and from the remote console, and maybe I can also demonstrate the downloading of the Llama 70B and 70B instruct. Just to demonstrate how fast it is working locally. Let's remove all of that first. Okay. And now let's run the HuggingFace with the HF transfer enabled. So first of all, for the just a small okay, looks like we need to we've got the PIP here, I believe. Yep. The only thing we need is the HuggingFace CLI itself. It's the HF transfer module, and HF transfer should be installed. Okay, right now it is installed. Let's download the model. First, we can download the pretty simple GPT-2 model. So as you can see, it's really fast. So there is a lot of small files here. So GPT-2 was transferred. Let's transfer the Mistral. So this is the consolidated safe tensors. As you can see, we utilize something like 1.65 gigabytes per second. And 1.665. Okay, we've downloaded. 1.65 multiplied by 2024 by 8. So almost, I believe the peak performance was during the extensive test was something like 15 gigabits per second. Right now we have 14, just a bit above 14 gigabits per second. That's good. So Mistral was downloaded. Let's download the Llama 31.8b. So as you can see, it has utilized the Python, but under the hood is the Tokyo runtime with the HuggingFace transfer module. It's integrated by the PyO3 framework. And as you can see, there is a massive multi-threading mode. So we almost done. Okay. Yeah, we've done with the Llama. And right now let's see how the Llama 70B will be downloaded and how fast. So we see that almost 5 gigabyte files just transferred during these seconds. So clean models is better to download on a host system and then host these models inside the S3 buckets for clean modules, and only fine-tuning model which are fine-tuned inside the enclave we can place from enclave to S3 bucket for fine-tuned models. As we can see, the performance of S5 CMD for this purpose was really good, and their clone as well. AWS CLI was a bit almost on a grade 2. So basically AWS CLI was 2 times lower in performance. Yeah. 2.2. Have you seen that? 2.09. I've seen the 2.2. I'm just amazed. Almost 19 gigabits. It's like, I think the 20 gigabits we can utilize. This server has the 15 or yeah, 50 gigabits networking card with the ENS Nitro optimized card, but we can utilize maybe only 20 gigabits from that. And also we should remember always that on EC2 instances there is a everything is managed. The EBS elastic block storage's performance for the disk subsystem for the block devices, the performance is manageable, so it can be increased, decreased depending on the load. Same for the networking cards, so performance can be increased and decreased depending on the performance. So that's why we see a different performance every time. So when we're prolonging this load on a disk subsystem or on networking subsystem, we can see higher numbers because the cloud just gives us more speed and performance. Yeah, let's see what kind of performance we have here. Yeah, fairly good. We can run this also inside the enclave, but this will take something like 20 minutes or 22 minutes for a Llama 70B inside the enclave. And obviously for Llama 70B we need something like 1.2 terabytes or 1.5 terabytes RAM because basically we need to place clean model and the fine-tuned model if we will fine-tune the Llama 70B. Yeah. Because we just available the almost all memory of the server, just remaining part is allocated and dedicated for the system, and 820 gigs is for enclave, but we can utilize I will show it up this we can use only like half of this memory because we have the RAM disk which consumes the 400 gigabytes, and 420 gigs was dedicated for the memory. So it's not evenly equally spread it out, separated between the RAM disk and the memory, RAM memory itself. So, and this is exactly because of the attestation, because the initramfs and RAM disk we have exactly because the hypervisor should perform the attestation before the system will be started in the runtime. So before it started in the runtime, we have some hanging of the Nitro CLI process because the hypervisor just performs the work on calculating the hashes to attestate the segments of the RAM disk. Cool. We've downloaded the Llama 3.170b. Okay. How fast it was? For Llama 70b, it was like 7 minutes. This is the walk log time. Good. Fairly fast. The same for the instructed model. Let's also download the instructed. I believe it will be the same. We also can use the accelerated instances, which can give us a bit more performance. So it is basically configured like that. Like that. So I already enabled the accelerate configuration for this S3 bucket, and we can use accelerating point, but obviously to use the accelerating point we should point out the accelerated endpoint in configuration file. This will give us a bit more even more performance. So right now we downloading from HuggingFace the Llama 3.17 to be instructed model, all the tensor layers. I was talking that performance can be increased for S3 buckets as well, so it will be on par with the HuggingFace. I mean, we can utilize something like 15 gigabits per second if we will use the accelerated endpoints for S3 packets. Even on the host system, the process just hanging a bit, although it continues to work. Side enclave, it just stops and cannot continue to work because of the air handling. Okay, the Llama 70B 3.1 version, instructed version have been downloaded. We've got, yeah, it was downloaded during the previous one was downloaded during 7 minutes. This one was downloaded during the 10 minutes. So because of the networking conditions, because the amount of data pretty the same, 265 gigabytes, right? Let's see. Yeah, the same. This one is just the same. This one as well. Yeah. Fine. 8 kilobytes is difference. So yeah, the Llama 3.1 8P is the 30 gigabytes and Mistral is 27 gigabytes. GPT-2 is the 5 gigabytes. So yeah, we can stop the demonstration on this, but I want to just to eliminate the boredomness with just a bit over time. But to waive out the boredomness, let's try out really cool stuff. So for example, we can enable no wait and start the parrot inside the enclave console. Come on. Oh, here it is. Yeah, maybe. Yeah, not so great animation, but nevertheless, let's kill it. Let's kill it first and try out the other one. So we will kill just first of all. We need to disable no wait and just use this one. Let's say for curl, because we need to just filter out the curl. Okay, this is the curl parrot 1, parrot life. Right, and we can actually kill all of this curl stuff. Boom. Okay. Let's try out the another thing. Possibly even more funny. Yeah, there is another parrot actually here. Anyways, here's our famous bird. We can run it inside the enclave as well. So cool. Nyanket. Not. And donut. All of these animations can be running inside the enclave. But we need to restart. Restart the enclave. Okay. When you run the shell inside the shell, sometimes the shell is just hanging, and we lost the control over the pipeline and the secure local channel. For this purpose, we at some point in the future we will implement the kill switch and some reboot procedure for our own init system, because we've got the own compiled init version as part of the enclave image. So, and we can so this init system can restart the pipeline, so to not lose the control over the enclave and not to reboot the enclave, restart the enclave. Okay, looks like enclave is almost run. Yeah, almost running. So this hanging is actually caused by the hypervisor, which utilizes the NAT secure module. Right now the hypervisor transferring the image. Oh, here it is. It's all already started. So as we can see, our init system, our custom init, have been started. So this latency on the start is exactly because we have hypervisor who performs the job on a NAT secure module. So because so it utilizes the NAT secure module, and this AAF file, which is 600 megabytes, it is passing as a byte stream through the NSM device and make the computation of the hashes. So this is the attestation process, and that's why we have that PCR registers for every EAF image file segment. That's kind of cool. Let's start the shell command again. Make deploy networking components. Yes. Run networking components. Yes. It is running. Yes, please. Yes, please. Download models from HuggingFace. Nope. Upload. Nope. 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 And right now we can run some good stuff again. We're not enabling the it's hanging again. Okay, so no worries, that can happen. This will be fixed. So the demo was pretty successful, so it's working, installer working, the proxy working, models transferring the loading from HuggingFace working on a host system pretty fast, on a enclave system. Inside enclave it works on the usual speed of HuggingFace Python toolkit without the Rust HF transfer module. Transferring to and from S3 buckets works fine. So everything works good. Good. So thank you for watching and see you next time.